Analyze draft on a design. In this video, we'll use draft analysis, accessibility analysis, and minimum radius analysis. In Fusion 360, we want to get started with the supply dataset drafted spur gear-analyze. This spur gear has already been drafted and it has a few other components in it. We expand the mold, you'll notice that there are three bodies: side B, side A1, and side A2. Creating a mold core and cavity for your plastic molded parts can oftentimes be an extremely important step to better understand how the parts are going to be manufactured. So let's take a look at the analyze and inspect tools that we have to make sure that this part can actually be produced. To get started, I'm going to hide side B and side A1, and I'm also going to hide the spur gear. I'm going to change the opacity of side A2 by right-clicking, going to opacity control, and setting it back to 100%. You'll notice that when I do this, the entire thing is still transparent, and that's because it's also set at the mold level. We want to make sure that we go to the top level and set the opacity of the entire component back to 100%. Next, we're going to use inspect and draft analysis. We're going to select this body, and for the direction, we'll simply use the pull direction associated with this outside face. When we do this, we need to make sure that we're looking at the appropriate amount of draft. Right now, it was going from 0.4 degrees to 0.5 degrees. But we need to set this back to 0, and then we'll use the up and down arrows to set it to -5 degrees and +5 degrees. When we look at this, you'll note that everything appears to be okay, but we're seeing red on these flat faces. If we instead change this to 0.45 and +0.45, you can see that everything is now green, meaning that we have plenty of draft. I'm going to OK the analysis, hide side A1, and bring back side A2. This wasn't included in the original analysis, but we can always edit. And for the body, we can select that body as well. And then we can show everything is blue on this specific body. Next, let's hide A1 and let's show side B. This one will require another draft analysis. So let's hide draft 1 and let's take a look at going to inspect and creating a new draft analysis. We'll select this as our body, and the direction is going to be the top face of the part. And once again, we're going to make sure that we set this to -0.45, and we're going to set it to +0.45. When we do that, you'll notice that everything does turn green. However, we are seeing some red faces here. This is telling us that we don't have enough draft in these areas. What we should be seeing is all green or blue, and you'll notice that we are getting some red areas. If we reduce this number to 0.4 and to +0.4 and take a look at the change, hopefully we'll see some changes in the gear, but you'll notice that we still have this red color. If we want to, we can reduce these values even further to get a better idea as to the range that we're going between. We also might need to change things like the direction that we're pulling, noting that what we're doing here is we've selected this face, and if you remember how we produced this originally, that face is already tapered. So this is actually producing a bad result simply based on our selection. So we're going to change the direction selection and make sure that we use this top center face. We know that we didn't draft that to either side in the Y direction, and now everything looks to be green or blue. So this tells me that this is a much better situation. However, this area is drafted in the opposite direction from the inside of the teeth. So that could be problematic, especially since in this case, it looks like it's going to lock itself into the mold. That tells me that I need to make some modifications to the original geometry. I'm going to OK the analysis. I'm going to keep it on the screen, but I'm going to make some changes to those features. If I take a look at the features that I have a draft that's applied to the inside faces. I'm going to right click and edit that feature. And instead of -gear draft, I'm going to set it to positive and say OK. I want to make sure that I hide the gear, and now I take a look at the results, and all of these faces are now green. That tells me that during the design phase, it was drafted the wrong direction. This is an important consideration because that means that the part would not be able to be removed from the mold. This is something a mold house would likely figure out, but it's always important to provide them the best model possible, and that will reduce any sorts of delays in production. It is also important to note that there are multiple ways to produce this geometry. We could take a look at inspect and look at things like accessibility analysis or minimum radius analysis. This will tell us whether or not tools can actually get into this geometry. For accessibility analysis, everything looks fine, so I'm going to cancel and not save that analysis type. I'm going to hide draft, go to inspect, and I'm going to take a look at the minimum radius analysis. When I do this, it's showing me that the minimum radius is 0, the maximum tool radius is 25, and it shows me the optimal is 0.77. If I reduce this value to say 1 millimeter, what that's actually doing is it's changing the range on the slider between 0 and 1. What this tells us is that we have a lot of sharp edges on this design. Turning the sharp edges option on, you can see that we have vertical edges, which will not be able to be produced through conventional machining operations. Sometimes geometry like this would be produced with things like spark erosion. There would be an EDM machine that had a custom shaped electrode that could remove the material for this geometry. Another option would be to modify the design so that there was a fillet on those corners and we could get a small tool in there. So again, it's important to keep in mind that the manufacturing of these parts is just as critical as the design, because you could make an extremely well thought out design, but if you can't produce it, then you're going to have to make changes anyways. So at this point, let's make sure that we save this design before we move on.